Hello guys, in this video we are going to be solving some equations which are quadratics in disguise, which then involve the use of logarithms. So what on earth did I just say? Let me just show an example. It's the easiest way. Okay, so here's an example. 2 to the power of 2x minus 6 lots of 2 to the power of x plus 5 equals 0. If we look carefully here, I can rewrite the 2 to the power of 2x like this. 2 to the power of x squared minus 6 lots of 2 to the power of x plus 5 equals 0. So again, this is just using index laws. Now, let's make a substitution just so that we can familiarize ourselves with why this is a quadratic in disguise. So let's just pick a letter u. Let's let u equal to 2 to the power of x. Okay, that means that the first bit is going to be u squared, because of course 2 to the power of x squared is going to be u squared. U squared minus 6u plus 5, which equals 0. Now we can solve this simply by factorization. So two numbers that multiply to give positive 5 and add to give minus 6, that's minus 5 and minus 1. So we simply have u minus 5 and u minus 1, which equals 0, which means that u equals 5 or u equals 1. Now remember, we have that u was equal to 2 to the power of x. So what that means is we have, instead of saying u equals 5, we say 2 to the power of x is equal to 5, or 2 to the power of x is equal to 1. Now with 2 to the power of x equals 5, I'm just going to solve that using the idea of taking logs of both sides. So we have log of 2 to the x equals log of 5. Using our log law, the power law, x log of 2 equals log of 5. And then we have x is equal to log of 5 over log of 2. Okay, and I'm just going to check what is that on the calculator. Okay, the calculator would give me x equals 2.32192 and so on. Whoops. Which is going to be equal to 2.32 to 3 significant figures. Okay, now let's take the other example here. So 2 to the power of x is equal to 1. So, well, there are two ways of looking at this. We can do it by taking logs of both sides, but actually, if 2 to the power of x is equal to 1, then x in this case must be equal to 0. Because if you raise something to the power of 0, you get 1. Again, we have a situation where we've got two different answers. Be very, very careful. Let's just check that both of those can work. So let me just write the original equation again. So let me just put x equals 0 as a solution. And the original question was 2 to the power of 2x minus 6 lots of 2 to the power of x plus 5 equals 0. So, yep, that's fine. We're able to put in both x equals 2.32 and x into the equation, and there are no problems there. So in actual fact, we've got ourselves two answers. X is equal to 2.32, to three significant figures, or x is equal to 0. Let's look at another example. Okay, here is the next example. Let me just rewrite it like this. So 5 to the power of 2x, I can rewrite this as 5 to the power of x squared. Take away 6 lots of 5 to the power of x minus 7 equals 0. So again, it's a quadratic in disguise. Let's just make that a little bit clearer. I'm going to take t this time. Doesn't really matter what letter you use, of course, as long as it's not x. Let t equal to 5 to the power of x. So therefore, the substitution would be t squared, take away 6t, take away 7, which equals to 0. Again, we can solve this by factorization. So two numbers that multiply to give minus 7, but add to give minus 6, that's going to be minus 7 and plus 1. So t minus 7, t plus 1 equals 0, giving us that t equals 7 or t equals minus 1. Okay, again, let's just check what that is. Remember, t was equal to 5 to the power of x. So, instead of saying t equals 7, I'm going to say 5 to the power of x is equal to 7, or 5 to the power of x is equal to minus 1. Let's work on the left-hand side first. So, let's take logs of both sides. I have log of 5 to the x equals log of 7 x log 5, using our log law, is equal to log of 7. Oops. And then x is equal to log of 7 over log of 5. And in our calculators, to three significant figures, that is going to be 1.21. Okay, and let's check the other side. 5 to the power of x is equal to minus 1. Let's take the logs of both sides. So we have log of 5 to the x equals log of minus 1. Now, there's a problem here. You can't have the log of a negative number. So actually what that tells us is 5 to the power of x cannot be equal to minus 1. Actually, from our section of exponentials, we should already know that 5 to the power of x is always greater than 0. Okay, so actually we've only got one solution for this one, and that is this one here. Let's look at another example. Right, this is our next example. That's 3 to the power of 2x plus 3 to the power of x plus 1 minus 10, which is equal to 0. Now, this one looks a little bit more confusing, but we can express the two powers there in terms of 3 to the power of x as such. 3 to the power of x raised to the power of 2. And this next bit, using our index law, we can say that 3 to the power of x plus 1 is 3 to the power of x multiplied by 3 to the power of 1. It's just using the first basic law, but in backwards. Okay, minus 10, which equals 0. So just writing that again a bit more clearly, we have 3 to the power of x squared plus 3 lots of 3 to the power of x. That dot there here and here means times, take away 10 equals 0. So now if we make our substitution, so let's let v, just choosing another letter, equal to 3 to the power of x. We have, let's just make that clearer, v squared plus 3 lots of v minus 10 is equal to 0. And again here we can solve this one by factorization. It's a quadratic. Two numbers that multiply to give minus 10 and add to give 3, that's going to be positive 5 and minus 2. So v plus 5 and v minus 2, which equals 0, giving you that v equals minus 5 or v equals 2. Okay, remember, v was equal to 3 to the power of x, so 3 to the power of x equals minus 5, or 3 to the power of x is equal to 2. Left hand side, if we take logs of both sides, we get that log of 3 to the x equals log of minus 5. Again, we run into the similar problem of logs cannot take negative numbers, and again we notice the exponential 3 to the power of x cannot be negative, so x, or you can put no real solutions. Okay, so we leave that one alone. On the right hand side we have 3 to the power of x equals 2, so we take logs of both sides. Log of 3 to the x equals log of 2, that's fine. Using our log law, we get x log of 3 equals log of 2. And then dividing both sides by log 3, we have x equals log of 2 divided by the log of 3. Using our calculator and to 3 significant figures, we get 0.631. Okay, let's look at one last example that's a little bit trickier and we will end it there. Okay, this one looks a little bit more complex, might require a few more little fiddly bits to do, but it's essentially the same thing. So again, we want to establish everything in terms of 3 to the power of x first. So we have this first bit where we have 4 multiplied by 3 to the power of 2x plus 1. So let's first of all rewrite this like this. 3 to the power of 2x multiplied by 3 to the power of 1. Okay. And then plus 17 lots of 3 to the power of x minus 7 equals 0. Now, this 3 to the power of 1, we can multiply it by the 4 to get 12. So that gives us 12 lots of 3 to the power of 2x plus 17 3 to the power of x minus 7 equals 0. And then we can rewrite the 3 to the power of 2x as 3 to the power of x to the power of 2. So like this, 12 bracket 3 to the power of x to the power of 2 plus 17 3 to the power of x minus 7 is equal to 0. Now, what we're going to say is let w, again just picking a letter, equal 3 to the power of x. That then means that 12 w squared plus 17w minus 7 is equal to 0. And again, we have another quadratic to solve. Okay, And this one actually can be solved by factorization as well. So that's convenient. So 12 times minus 7 is minus 84. Just going to write that here. So I need two numbers that multiply to give minus 84 and add to give 17. And we have that is 21 and minus 4. So we have 12w squared plus 21w minus 4w minus 7 is equal to 0. Factorizing the left-hand side, we have that this is going to be 3w multiplied by 4w plus 7, take away 1, lots of 4w plus 7, which equals 0. Taking out a common factor of 4w plus 7, we have 4w plus 7, open bracket, 3w minus 1, which equals 0. And again, we get that w equals minus 7 over 4, or w equals a third. Again, just to remind ourselves, w is equal to 3 to the power of x. So, instead of saying w equals minus 7 over 4, we say 3 to the power of x is equal to minus 7 over 4, or 3 to the power of x is equal to 1 over 3. Okay, now let's look at the left-hand side. We take the logs of both sides. Log of 3 to the x equals log of minus 7 over 4. We run into our familiar problem here. We cannot have the log of a negative number, so no solutions. So let's leave that one alone. On the right hand side, we can do the whole taking logs of both sides. If you know your laws of indices, we see that 3 to the power of something is equal to 1 over 3. We should know that x is equal to minus 1. But if you don't spot that, not to worry. You can use the idea of taking logs of both sides, which I'm going to do. So log of 3 to the x equals log of a third x log of 3 equals log of a third. Again, just using my log laws there. And then I get that x is equal to log of a third over log of 3. And my calculator will give me that x is equal to minus 1 exactly. So in this question, this is the only solution. Okay, take a moment to look back at all the examples that we looked at and be sure to have a go at some of the other questions provided. That's it for now. Take care.